My name is Aleksey. I am the CEO and co-founder of Natilus. I spent about 2 decades leading engineering teams across aviation, specifically commercial, general aviation, and also military programs. So Natilus is an up and growing startup. We originally were based out of the Bay Area, but recently relocated down to San Diego. The vision of the company has largely remained the same, is to create a more sustainable, more efficient way to transport not only people, but also cargo as well. Natilus currently has 2 products in development. The first one is the Kona Regional Freighter. That's meant to connect smaller regional airports to larger hubs. A good example might be Eugene, Oregon to Oakland, California for the FedEx Nightly Sort. The second product is a passenger and a freighter aircraft called the Horizon. That's meant for cargo and passenger delivery, let's just say from East Coast United States over to the West Coast, capable of transatlantic operations, inter-Europe, and then inter-Asia. So the blended wing body has been around for quite some time. We believe the time is now to bring this type of idea and product to market. Specifically, our customers are focused on more sustainability and higher operational efficiency. So in a traditional tube and wing airplane, the wing carries about 90% of the lift and the fuselage 10% of the lift. So there's a lot of inefficiencies in that. The blended wing body marries the two together, where the fuselage actually contributes 50% of the lift. So in this case, the wing is producing 50% and the fuselage is producing 50% of the lift, creating more aerodynamic shape of the airplane, reducing drag, and then overall operational efficiency for our airline customers. So Natilus is a company. We design, build, certify, and sell our airplanes to airline customers all across the world. As an example, our beachhead market is in the freight sector. So we have strong relationships with large integrators such as the UPSs and the FedExes of the world. The second product is a dual-use passenger as well as freighter. And so now we've expanded the market to large airlines on a global level. The company to date has over $19 billion spread across the 2 products. So we have finished a lot of the research and development work on the first Kona product. The aircraft is actually in assembly here at our facility in San Diego. We anticipate first flight in about 24 months. At the same time, on the Horizon, the passenger and the larger freighter aircraft, we've already started research and development on that. We're scheduled to do 2 wind tunnel tests next year, helping us get ready for first flight later this decade. So the blended wing body, especially when you focus it or look at it through the lens of the passenger market, offers a couple of unique value propositions to our airline customers. The first one is sustainability. A lot of our airline customers have very aggressive sustainability goals by 2050, specifically trying to be carbon neutral. The second time, we're actually able to carry more passengers for the same weight of aircraft. And so that allows us to use more efficient engines, helping increase the profit margin for our airline customers when it comes down to fuel. And third of all, we can actually make the airplanes lighter, not only because of carbon, but just due to the footprint of the blended wing body and the way it lays out, allowing us to actually get into smaller airports for a lot of our major airlines, connecting smaller airports to larger populations as well. So a big part of our research and development effort is, of course, computational fluid dynamics. We've partnered with Luminary, which has been an incredible partner as we develop both the products. What really gets us excited about Luminary is the ease of use, specifically taking the meshing down to almost a turnkey solution for us. So being able to generate faster meshes, reducing the engineering time on the computer, as well as being able to produce solutions a lot faster with the unique GPUs capability that they have. I think being a young company producing large airplanes, specifically, we sell our airplanes quite a bit into the future. Understanding how airplanes behave is very important for our airline customers. So we focus quite a bit on fuel performance, which would be your high lift operations, as well as the performance or drag performance of the aircraft, because we take a lot of that data and help firm up solutions and contracts with our future customers. So the team is quite familiar with a lot of the CFD tools on the market today. We've used quite a bit of the NASA legacy tools recently. The challenge with those tools is specifically the meshing as well as the runtime. And so usually a solution for us would take 6 or 8 hours for an engineer to mesh. With Luminary, that's now down to 5 to 6 minutes. And so that streamline of workflow is very important for us. On the tail end as well, what Luminary does really well is performing a lot of these solutions out in the cloud. And so we don't actually have to stand up our own CFD clusters. We're able to do turnkey operations, allowing our team to scale up for CFD solutions when we need them, but also scale down when we have lulls in the design as far as aerodynamics. I think for us, having a small team, being able to work hours for engineers is a lot more important for us. And so again, having a streamlined workflow that is actually a lot more efficient and brings back time for analysis, and less so the actual meshing or the grunt work and setting up solutions, is a very key value proposition for us. For us, blend-wing bodies are very tough as an aircraft design. Specifically, everything is very integrated and interrelated. And so for us, when we look at high lift as an example, the wing analysis, we're also looking at the fuselage and vice versa. On things such as performance and drag, of course, the moment you change the position of the fuselage, it changes the lift characteristics within the fuselage as well. So typically for us, we look at the overall solution, not only from high lift, drag, but also stability and control. And having, again, that meshing capability that is so streamlined is really a key selling point for us. I think being a young startup going against large incumbents, there's a lot of challenges as we have, and having scalable solutions that allow our small team to move faster to compete against these large giants is very important. So what Luminary is offering to us is increased time to solution, increased iterations. We can run multiple studies at the same time for parametric analysis. And that, of course, decreases our time to market, which our customers view as a huge value proposition as for our products in the company. I think what gets us excited the most is the support system that comes with it. So being able to answer questions not only on the technical side, but also how to make the product better. Being able to work with Luminary has been a very valuable value proposition. Because if we can decrease that time to create these quality meshes and then being able to spin them up at scale, that creates a very interesting value proposition for us. So we've been using NASA codes for a long time. They're tried and true and understood, but a lot of these tools don't come with a really great meshing solution. And so especially if you think about CFD tools as a whole, 80% of it is really the mesh. And so being able to iterate on that quickly, being able to scale the mesh based on the problem or the challenge that you're trying to look at is very important for us. On top of that, we see a lot of these new tools come into the market, specifically artificial intelligence, adaptive meshing. How do you actually integrate that into a more modern solver? And again, create that scalability within the solution and the team. And I think those value propositions are very apparent in Luminary and still missing in the NASA solvers. I think as a startup, we always try to think of a company in a box or solutions in a box. And so even though you're a team of, let's just say, 10 today, and you could be a team of 50 tomorrow, are the solutions that you're bringing in-house actually scalable with a team size? And then can that actually get us into a faster movement or a faster swimming lane as far as company development for our products? And I believe Luminary has got all those tools built in for that scalability of team. Again, we talked about being server-based and the ability to run solutions in the cloud, the automatic meshing tool that's been able to also provide different solutions or different refinement tunes to actually create the meshes that we need. And then lastly, new cutting-edge ideas such as artificial intelligence and adaptive meshing solutions as well. When I first started running CFD about 20 years ago, scalability and just time to solutions was always a very important metric. Typically, it would take one of our engineers about 8 to 10 hours to create a mesh for anything high lift or drag performance. And then we'd also have to run it our own in-house cloud or cluster. And of course, over the last 10 to 15 years, we saw huge advances in computing. The big pieces for us is time to mesh and creating that scalability of mesh size to create the right proper solution or mesh for the solution. And of course, it's also the time to actually run that solution as well. And so we've seen times to run in Luminary Cloud drop from 10 to 14 hours, something closer to about 5 to 10 minutes. And that is almost a 100x increase in time to performance while also doing it in a more scalable and reduced cost for the company. I think a lot of it comes down to the maintenance of the cluster. If you have your own in-house cluster, you usually have your own IT department who is essentially updating and working that cluster. And there's a lot of heavy maintenance involved with it. Having a solution out on the cloud essentially removes that job function internally and allows our engineering team to really focus on what they do best, is essentially designing and analyzing these airplanes. I think for us, as we keep looking ahead into a lot of our products, specifically its flight testing as well as new developments, we see that Luminary is going to be a fundamental tool and the core pillar of the company's engineering technologies. Specifically the scalability of it again and the ease of use as well as the cost to run these heavy simulations, it just keeps going down. And so we see that trend to continue. As an example, doing flight tests per hour, you'll be spending about $5,000 to $7,000 per flight test hour just to grab a handful of points. Where Luminary Cloud, you can do the same thing in less than $100 depending on the problem that you're trying to solve. I think with the recent advancements in AI, especially if we can generate these large data sets for the AI tools to actually learn, I think adjoint adaptation, or actually giving CFD tools the design parameters that you're looking for, and have the CFD tool actually change the geometry of the airplane is going to be a very important, I would say, tool over the next 5 to 6 years. And I know we've had quite a bit of ideas within the NASA codes and a lot of other solvers on how to do it, but I think the key that we've been missing was the computational horsepower, which is now readily available, then coupled with the artificial intelligence and large language models as well. I would say it's ease of use, the idea that the product is always evolving in various feature sets, which is a lot faster than a lot of the legacy codes that we've been using to date, as well as bringing in new technologies, again, such as artificial intelligence, and doing this in a scalable way.